Hello everyone, welcome to the one more video of operating systems. In this video, we will be discussing about process definition, process states and its state transitions, process control block and context switching. What do you mean by a process? Normally, a process is defined as a work unit in the system. In operating systems, a process refers to a program which is under execution, and it is the basic unit of execution that an operating system will manage. Each process has its own memory space, resources and execution state. Because system can have collection of process like user process executing use code or operating system process executing a system code and so on. A process can be program in execution. Execution must be sequentially processed. Understanding the process and how the operating system manages them is fundamental to design an efficient, reliable software systems. Operating systems provides necessary abstractions and mechanisms to manage process effectively, ensuring efficient resource utilization and providing a stable execution environment for applications. A process defines the fundamental unit of the computation for the computer, and the various components of the process may be object program, resources, data, status of process execution. Different states of the process. Normally, the process can have the different states like new, ready, running, blocked, or waiting, terminated, or finished. Now, these are the different states of the process, where new here indicates that the process is being created. Ready indicates processor is assigned with or the process it's ready to execute. The next case is running. The process is currently being executed. Blocked or waiting. Here the process will be waiting for some event to occur. That could be an IO completion. And next we have terminated or finished. The process has completed its execution. Now this is what the process state transition, you call it as the state transition diagram of the process. Okay, so here you can see different states of the process: new, ready, running, terminated and waiting. Now here you can see the different state changes, where new to ready. So here new to ready indicates that the operating system will move the process from the new state to the ready state, which says that the process is ready to execute. Next we have here ready to running state, where here you can see scheduler dispatch. Now, what do you mean by a scheduler, or what is the role of a scheduler is, suppose if we have n number of processes which are under execution, the scheduler will schedule which process need to execute first and which process need to execute next. Now, in the case of ready to running state, when it is a time, select a new process to execute, and the OS will select one of the process in the ready state. That is what ready to running state indicates. Now here you can see running to terminated, where the process completes its execution and goes to the terminated state. Now here you can see running to ready state, where here you can see an interrupt, where an external interrupt has been occurred. Okay. Next you have running to waiting state, where you have an IO event, or we are making some process to wait for some time until an event is executed. Now waiting to ready state here indicates that, so after the IO event has completed, now again the process will be ready to execute. Now this is what the process state transition diagram is. Next, process control block, which is very important concept. Now what a process control block or PCB does is, it will manage all the process, or it will keep track of all the process. I said that we can have n number of process which will be executing, where each and every process will be having its own process control block. Now if one process is under execution and second process need to execute, and the first process need to wait. Now what the process control block will do is it will store the state of that particular first process where it is going to stop or it is going to the wait state, and then the second process will be executed. Normally this process control block consists of the various pieces of information about a process, allowing the operating system to efficiently manage and control its execution. So this process control block process the management functions like process scheduling, context switching, resource allocation, and inter-process communication. Process scheduling here indicates, which I have explained in the previous slide, saying that scheduler. So now this scheduler, here you can see scheduler dispatch. Now this scheduler will schedule the different process, which process need to execute first and which process need to execute next. That is what done by the process scheduling. So context switching is what here. Suppose one process is under execution and other process need to execute. Process and the first process will be in the waiting state and the second process will be under execution. Now, this is a concept of context switching. Resource allocation, where we have a single resource which is need to be shared by n number of process. So we are going to schedule accordingly that particular resource need to access should be accessed by different process at what time. And inter-process communication, so this is the communication between the process. So by storing all this information about each process in a structured manner, the operating system will efficiently manage the execution of the multiple processes concurrently while ensuring the proper resource utilization and system stability. Now here you can see the process control block or the data structure of the process control block, where you can see the process state, process number, a program counter, registers, memory limits, and list of open files. Now here you can see process state. So as we have seen the state chart diagram of the process, now suppose two processes are under execution. The first process is under execution and the second process need to execute. Now the first process need to be in the waiting state. So that is what process state is. The currently executing process is under which state? That is stored in the process state. Next, process number, store the number of process like P1, P2, P3 like that. Next we have the program counter, which indicates the address of the next instruction in the process to be executed. So CPU registers whenever an interrupt occurs for later continuation of the process, some important CPU registers has to be saved. This is what about the process control block is, and which is very, very important, and for each and every process we will be having the process control block, which keeps track of the information about the process like the process number or the state of the process or the registers or the program counters like that. Next, this is context switching, which is very important, and this will be the fundamental operation which is performed by the operating system to manage multiple processes which execute concurrently a single CPU. It involves in saving the current state of process, including its CPU registers, program counters, and other information, and loading the state of another process or thread so that it can resume its execution. So normally the context switching is the mechanism which is very important for multitasking and concurrency in the modern operating system, where it will allow the multiple process share a single CPU efficiently. So here you can see that here is how the context switching typically works. Interrupt handling, saving the context, select next process, load the context, and resume its execution. Okay, now here you can see the context switching process, where you can see process P0 and P1 which are under execution, but we need to execute only single process at a time. So P0 is under execution. So here if an interrupt has been occurred, so now this particular process will save its state in the process control block. I said each and every process will be having its own process control block. So whatever the related information about this process P0 is stored in the process control block 0, PCB 0. So till this PCB is 0 stores the data, P1 will be under idle, and now the process P1 is under execution, where it will reload the data from the process control block 1. Now P1 will be under the execution state, where P0 will be under the idle state until process P1 executes its completes its execution. Now after executing, P1 executes. Now again P0 will execute and it reloads the state from process control block P0. Now here the thing is that, suppose if P0 is got an interrupt, now the state, suppose P0 is at running state, so that state will be saved in the PCB 0, that is process control block 0, and at the time of reloading, process P0 will start again from the state where it has been stopped, that is from the running state. Now this is what the context switching concept is. Now in this video we have seen about process definitions, process states and state transitions, process control block, and context switching. Thank you.